Hey math kids, today we're going to talk about the laws of exponents. We are in section 3D and we will eventually get to example 9, but I want to talk about a few things before we get there. So first thing, if we have two things raised to an exponent, and we're multiplying them together, we add their exponents. If we have two things, it's important that we have the same base. And then if we're dividing, we subtract their exponents. If we raise to a new power, so a to the m to the n, then we multiply the exponents. If we have two things raised to an exponent like that, two things being multiplied together, we can distribute that exponent. And if we similar thing, if we have a fraction, we can distribute the exponent to the top and the bottom of the fraction. And everything raised to 0 is 1. That's one that kids get kind of confused on. And negative exponents look like this. It means we're on the wrong side of the fraction. So right here we can think of ourselves as being on top of the fraction because there's an implied division by 1 right here. And so really we're just taking this, bringing it down to the bottom, and then making it positive, and then we have our placeholder of 1 up there. And similarly, if we have 1 over a to the n, negative n, that would just be a to the n, because we would bring it up top. And those are our exponent rules that we're going to use. They are in your book on page 71, if you need to look at those again as we continue through the video. So now we're on example 9. This is 7 to the 4th times 7 to the 5th. And then we also have p to the 6th times p squared. So this is using that first rule, where if we have the same bases, we just add the exponents, and we do 7 to the 9th. Right here, we're going to also add the exponents, and we get p to the 8th. Next example, number 10. We have 5 to the 6th over 5 to the 3, and x to the 11th, and x to the 6th. So this is using the next exponent rule, where we subtract exponents. So this is just going to be 5 to the 3, and then if we do 11 minus 6, we get 5, so it's x to the 5. Now we're moving on to example 11. So we are going to use the next rule. So when we have a base raised to an exponent and then raised to another exponent, we multiply. And so this one's just going to be 3 to the 10. Same thing here, x, 3k. 3 times k would just be 3k. Okay, now we're moving on to example 12, and it says write as a power of 2. So we got to do it to 16, 1 over 16, 1, 4 times 2 to the n, and 2 to the m over 8. Okay, so 16 raised to the power of 2. We can just kind of go through. So it's 2 times 2 gives us 4, times 2 again gives us 8, times 2 again gives us 16, so that must be 2 to the 4. Now 1 over 16 is going to be the same thing, so it's going to be 1 over 2 to the 4, but we're going to use that negative exponent rule in reverse, and so we want to bring this up top, and so we need to change it to a negative 4. So 2 to the negative 4 is like saying 1 over 16. This one we're going to use, for the 1, we're going to use the rule that anything raised to the 0 power is 1, and so simply just write it as 2 to the 0. Okay, this one over here, we're going to use a couple different rules. So 4 can be written as 2 squared, and then 2 to the n. And now we need to combine this. So our very first rule said we add exponents in this situation, and so we get 2 to the 2 plus n. And the final one over here, we're going to use similar thinking to that one. So we're going to have 2 to the m over, now 8 can be written as 2 to the 3, and then our exponent rule says we need to subtract exponents, so it becomes 2 to the m minus 3. Okay, now we're going to keep moving on. This time we're on example 13, and it says express in exponent form with a prime number base. So let me just write the problems down. 9 to the 4, 3 to the x over 9 to the y, and then 25 to the x. Okay, so we have to get our base to be a prime number. So 9 can be written as 3 squared. So do you see how this is the same thing, because this is really just saying 9 to the 4th. Now our exponent rule says to multiply these together. So we're going to get 3, and then 2 times that is 8. And we're going to keep it like that, because the direction said write as a prime number base. Okay, we're going to once again change the 9. So we get 3 to the x, and then 3 squared raised to the y. So we get 3x, and then the bottom becomes 2 times y, so 3 to the 2y. Then we have to use our exponent rule where we subtract. So we're going to say 3 to the x minus 2y. Okay, now on this one, 25 can be written as 5 squared. We use our rule where we multiply these together, so we get 5 to the 2x. Alright, let's keep moving on. This time it wants us to write our things without brackets. Just have to get some room up here. So we have 3x to the 3, and we have x over y to the 4. So what we can do on this one is we can distribute the 3. So this can become 3 to the 3 times x to the 3. 3 to the 3 is 27, and then we just have x cubed. This one we distribute the 4 to both pieces, so we get x to the 4, y to the 4, and that's all we need to do on that one. Okay, the next one